Assalamualaikum and good afternoon. My name is FAUZIAH Aziz. Today I'm going to present my research entitled Development of Characteristic of Biaxial Interlocking Block as the load-bearing wall subjected to the compression load. As an introduction, masonry is a material as old as the civilization, has records of excellent performance and lasting qualities. The material widely used because it has an aesthetic appearance, durable, economical, and easy to assemble as a building material. The continued existence of the historical and ancient buildings around the world is the best indication to explain the durability, resistance against climate change, low cost, and availability of masonry. The state art of masonry biaxial interlocking block or BIB is a new masonry unit that has been introduced to the industry. This masonry unit consists of multiple groove and tongue as a locking system in X and Y direction. The interlocking blocks give various advantages such as reduced self-weight, reduced design load, simple handling, simplification as building components, increased compressive, reduced workforce, increased construction quality and quantity, and reduced project construction time. Furthermore, the interlocking block units can be applied as a load-bearing wall by a reinforced method, which is putting the grout material. This study focuses on biaxial interlocking block properties and behavior as a walling unit with the interlocking mechanism through the grooves and tongue under uniaxial compression load. The main features which masonry wall must offer are the compression, tensile, flexural, and shear strength. Generally, masonry is strong in compression but weak in tension. The compressive behavior of masonry due to vertical load of a crucial importance for design and safety and has been studied extensively over the years. Therefore, this is the typical situation to the new building material which lack of technical data and the high motivation to investigate the behavior and the capacity of the wall was under impressive load, which is stated by Mohammed, FAUZIAH, Ford, Martin, and Lorenko, 2021. So, the problem statement for this research is starting with the current application of the material of masonry in the construction project. Okay, as we know, cement and brick is most preferable masonry unit in masonry construction. It is due to the advantages of the cement and brick, which are low cost material, light in self-weight, and etc. However, there are several weaknesses of the brickwork masonry, such as labor, time consuming, and quality of the project. Interlocking system, a system that promoting separation and achieve the stability through the interlocking mechanism. So the objective of this study is to investigating the properties and behavior of biaxial interlocking block (BIB) subjected to compression load in masonry construction. So to ensure that BIB appropriate following the British European Standard BSEN 1996/1/2/2005 masonry structures, the BIB item needs to study inside and out. Therefore, the objective to achieve this aim are: First one is to develop properties of BIB single unit with and without grafting material, and then compare to the semi-assembled and solid block properties. Second one is to evaluate and analyze the mechanical properties and behavior of poly system using grout and ungrout BIB compared to the semi-assembled wall and solid block walls. Third one is to assess the correlation coefficient and develop mechanical properties prediction equation of grout and ungrout beam, semi-assembled and solid block walls. The fourth one is to perform and conduct a parametric study using the established model and evaluate the walling properties due to the changes of parametric value of grout BIB, ungrout BIB, semi-assemblies, and also solid blocks wall. And the last one is to calculate and develop the capacity reduction factor in determining the design resistance of the BIB unit, semi-assemblies, and solid blocks wall. So the scope of study, the scope of this study covers a little and objective of the studies, and can be divided into several parameters. Okay, first one is material of the research, which is a biaxial interlocking block, semi-assembled, and also solid block unit. So the properties. So in identifying the properties of BIB and other masonry unit, all the material will be tested under compression load, right? So and also for finite element modeling, FEM, okay, the FEM was performed to produce the established model for validating process of the laboratory work with the software Abacus 6.14, and the simplified micro modeling was chosen based on the previous study that this method is suitable for the new masonry unit material purposely for the interlocking concept. Okay, so this is the properties of biaxial interlocking block. Okay, this is a newly available interlocking system produced by innovative precast builders in Berhad, and the dimension of the block is 700 mm times by 100 mm and times by 150 mm. And this system offers multiple groove and tongues unit on the top of BIB. This is a little bit of a literature review for interlocking system, and a part of that, okay, based on Farabushi 2019, a system that may eliminate the use of mortar, and it may prevent the assembling of the block from separation during construction. And another one, a statement by Stump, Ramos and Lorenco, 2015, interlocking mechanism allows the block to lock themselves during the erection of the walls by eliminating the use of mortar joint. So this is the research methodology of the BIB newly masonry unit. Okay. And this is data collection and data analysis. The first one is material properties. Okay, this is the fracture strength test data, and this is the procedure of fracture strength test. Okay, this is an example. Okay, and this is the process of modeling and validation process on experimental result of the BIB load bearing masonry walling system subjected to compression load using Abacus finite element analysis software version 0.14. In this modeling approach, the concrete damage capacity model were chosen in order to represent the mechanical behavior of blocks and mortar. According to Kipchik and Kamensky 2011, this model is an adaptation of the Drucker-Prager model, which is also used to represent the mechanical behavior of brittle materials. And concrete damage capacity is widely recognized as a precise and practical constitute model to simulate concrete behavior of brittle material. And this is the concrete damage capacity model, consists of tensile stress diagram and compressive stress diagram. And this is the data for full ground block and for hollow block. Okay, this is the Gantt chart to monitor my study throughout the year. For list of publications, there are 4 articles that has been published during the study. Okay, start from 2019, 2020, 2021, and June 2023. And last but not least, for the status of thesis writing, okay, chapter 1 is completed. Chapter 2, 3 is under second draft. Chapter 4, okay, objective 1, objective 2 was completed. Objective 3 and 4 is about 40% progress, and objective 5 is about 10%. Okay, and chapter 5 is not available. And for my planning to the next semester, I'm going to perform parametric analysis on modeling, and also hopefully can produce a final thesis writing by producing chapter 4, 5, and 6.